We're at Playa de Monsoul on a slightly windy day, and behind me you can see the structure with these columns which start off vertical and then fan out on either side of that central structure. The rock type is dacite, so it's a relatively viscous magma, okay? And the central part of that is directly above the conduit where the eruption was happening. Okay? This magma is very viscous. It's already started to break into columnar jointing, so it's deforming in a semi-brittle manner. But as it comes out onto the seafloor in this case, it's still a little bit ductile, so it starts to flop over. And so you get these fanning columns, and these horizontal regions here are actually still columns. So the columns fan out. Okay? As it's cooled by the seawater, and we know that it's a sub-aqueous eruption because there's a lot of epidote alteration, which is a hydrous alteration which happens during circulation of fluids as the crystallized magma cools down on the seafloor. As it's cooled by the seawater, it's getting more and more brittle, so at some point actually it starts to make boulders and blocks. So as you go away from these horizontal platforms and above it, you can see that becomes less clear, and it's actually breaking up into a whole range of rubble of different sizes. And we would call this an autobreccia because it was formed during the eruption and it's still in the place where it was formed. It's not been moved anywhere. So it's a nice example of an autobreccia. And this is actually a classic example. This is Monsoul-type lava dome, and we're here at the Playa de Monsoul, and they're named after examples that you see around here. Big shout out to Chris.